Hi everyone, it's Mrs. Summer here to talk about lesson 701, exponent rules. In this lesson, students will be able to evaluate exponents by applying the product rule, power rule, and quotient rule. So here's a few weird rules that you guys need to keep in mind as you're doing exponents or evaluating exponents. Anything to the power of 1 is itself. So example, 5 to the first is just 5. And then this one is important. Anything to the power of 0 is 1. So example is 5 to the 0 power is equal to 1. The product rule. So if you recall, multiplication is just repeated addition. So in order to multiply exponents, you add the exponents. Example, 3 to the 4th times 3 to the 5th. 3 to the 4th is just 3 times 3 times 3 times 3. And 3 to the 5th is 3 times 3 times 3 times 3 times 3. So if we add up all of those 3's, we get 3 to the 9th. Here's another example, x to the 6th times x to the 7th. When we write that out, we get x times x times x times x times x times x, and then times x, 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 times x, 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 x. And when we add up all of those x's, we get x to the 13th power. If there's a coefficient in front of the variables, you multiply the coefficients and then add the exponents. So add the variables, but I'm going to say add the exponents. Okay. So here's an example. 3 to the 4th, or 3y to the 4th times 4y squared. What we're going to do is 3 times 4, because we multiply the exponents, and then y times y times y times y times y, we add up all the y's, we get y to the 6th. You try. Answer the following questions. So this first one, we have y times y to the 12th. Remember, if it doesn't have an exponent, it's just 1. So 1 plus 12 is y to the 13th. The next one is 3 of them, and we have s to the 4th, s to the 8th, and s times s to the 3rd. Well, we just add them as well. So we have 4, we ended up with 4 plus 8 plus 3. 12 plus 3 is 15. So we have s to the 15th power. Now this one, we need to multiply our coefficients and then add our exponents. So we have 2 times 3. And then x to the 12th plus 12. So we have 6x to the 24th. So the power rule. So exponents are just repeated multiplication. So the rule for the power rule is that x raised to some power, all raised to another power, is equal to x to the m times n, so power times the power. So we're multiplying powers this time. So in order to evaluate a power to a power, so this example is easier to do as an example. X to the 4th, all squared. Well, what it's really saying is that we have x to the 4th, which is x times x times x times x, and then another group of x to the 4th, because we're squaring it. So x times x times x times x. Wow, that was hard. And then when we add them up, all of the x's there, we have x to the 8th. But it's easier, instead of writing all those x's out, to write it as just x to the 4 times 2, which is x to the 8th. Here's another example. Y to the 5th, all to the 4th power. So what we do is y to the 5 times 4, which is 20. If there's a coefficient in front of the variable, you take the coefficient to the exponent power. So example, 3y to the 4th, all squared. So we have to square the 3, because it's inside the parentheses. So we have 3 squared, and then we multiply the exponents for y. So y to 4 times 2, so our answer would be 9y to the 8th. So you square the 3, and then you multiply those two exponents together. You try. Solve the following problems. Okay, if we were going to start, we have y to the 8th all raised to the 9th power, which is y to the 8 times 9, which is equal to y to the 72nd. This next question is 5x cubed all to the 3rd power. So I need to take 5 to the 3rd and then x to the 3 times 3, which is equal to 125 x to the 9th. If you are given a problem with actual numbers in it, you have to evaluate that actual number and not just leave it as 5 to the 3rd. The next question is 4x cubed y to the 7th all squared. So even though there's multiple variables in here, you don't do anything different. You can only combine exponents or multiply or add exponents if your base. So your base is the number or the letter, so x and y. So you can't combine x to the 3rd and y to the 7th to get xy to the 10th. You only do x's and then y's. You keep them separate. So when you expand this, you get 4 squared times x to the 3 times 2 and y to the 7 times 2. So I'm left with 16 x to the 6th, y to the 14th. So the last rule we're going to talk about is the quotient rule. So division, quotient means division, is just repeated subtraction. So example, we have x to the 5th divided by x squared. When we expand that, we get x times x times x times x times x divided by x times x. Well, when we take that and we expand it even further, now we're just going to subtract those two x's because we're dividing by them. So x times x times x times x times x minus x times x. And when we do that, we cancel 2 of those x's. And we are left with x to the 3rd. The other example is 4y to the 7th divided by 2y squared. Just like when we did the power rule and you were multiplying numbers or letters with coefficients, you're going to divide the coefficients. So here, 4 divided by 2 is 2. Then we're going to subtract the exponents. 7 minus 2 is 5. So your answer would be 2y to the 5th. So just like in the previous example, if there is a coefficient in front of the variable, you divide the coefficients. So you try, evaluate these expressions. Okay, for the first one, we have f to the 3rd minus f, or divided by f. Oops, let's change the size. So remember, if it's just the variable, it's to the 1st power. So we're left with f to the 3 minus 1 equals f squared. This next one is we have x to the 7th divided by x to the 6th, and we have x to the 7th minus 6, which is just x to the 1st, or x. This next one, we can only do it with like bases, so the s's are one thing and the t's are another. So here we're going to have s to the 10 minus 2 times t to the 8 minus 1. So I'm left with s to the 8th, t to the 7th. That is not a 7. 7th.